Hello, welcome to my YouTube channel. My name is Bashiru Ibrahim. Today I'll be doing primary substation grid grounding design app with you. This app or this GUI graphic user interface is designed by the engineers in ECG Training Center. So in this design or on this design, you'll be able to carry out ground grading design. So what it means is that when you want to carry out your primary substation grade grounding design, you need to consult this app. This app is very delicate, effective, and efficient way of carried out primary or secondary substation grounding grid design. So we have two interface on one, which is we have the 50 kilograms of human or animal weights according to IEEE Standard 82000. We also have the 70 kilograms of human or animal weights according to IEEE Standard 8200. So you can do the 50 here and you can also do the 70 here also. So you can see, as you can see, before you do it, you have to refresh the GUI, and then you have to select your connector type that you want to carry out with the design, with the grid design. So you know, before you do grounding grid design, you must have all this field data. So in this tutorial, we are we will be learning how to use the GUI or the graphic user interface, and then on the subsequent video, we will be doing or we'll be learning how to carry out this uh, grounding grid design or grounding grid design. Yes, so without wasting so much time, let's straight and then go ahead with our or we are going to go ahead on how to learn or how to design substation grid grounding using this graphic user interface. So let me go out. Let me go on. So before that, we have to choose your type of conductor. So I'm choosing the copper commercial hard ground here, and then I'll go on and then start inputting my data that I have gathered from the field. And these columns are, we have the length of the grid, we have the breadth of the grid, we have the distance between conductor of the grid conductor. We also have the number of grid conductor in the x direction, number of grid conductor in the y directions, number of grid rods, the resistivity of the soil of the grid grounding environment, the resistivity of the crush layer or the gravel or the surface layer of our substation grid grounding. We also have the thickness of the surface layer, now the total size of the area. So you can do rectangular, T and L shape of this grid grounding app. Okay, so you can also input your nominal current or the current of the transformer and then the tripping current duration. And then you can also enter the conductor depth of the grid grounding. Okay, so we are referring to this paper for our authenticated or to verify whether our app is in good shape. So you can see I have downloaded this paper from IEEE. So this paper is written by these two gentlemen, Vadim Balif and then Pravish Karan. I think they are from India. Okay, so we get the data or we took the full data from this book, and this paper is carried out in one of the substation in California. Yes, California, USA. Yes, so you can also download the paper and then look at and then compare the values to the values we're getting from this app. So according to the paper, the length of the the substation is 90 by 100, which is the length and the breadth. Now the distance between the conductor, between the grid conductor is 5 meters. We also have the number of conductor in the x direction, which is 4. Then on the y direction we had 11. The number of the grid rod we have 4. The first resistivity we have 57.4. We also have the resistance of the surface layer, which is 2500, and then the length of the buried conductor or buried rod is 3 meters. Then the thickness of the surface layer 0.1016. Then the total area of the grid yard, which is 9,000. Nominal current of the transformer 4595 amperes. Then we also have the tripping current duration, which is 0.5, and then the depth of the conductor, it's 0.4572 meters. So when I enter these values, it's going to produce me all this column. We have the grid current, the derated factor, the mesh voltage, grid resistance, GPR, tolerance touch, the faulty current or the ground fault current. We also have the grid conductor size here. We'll be getting the diameter of the conductor, the calculated step voltage, the corrective weighted factor, the corrective weighing factor, the geometric spacing factor, and then the step factor. Also, we can also get the irregularity factor and then the total length of the buried conductor. So the moment I just enter here, we are going to see some values here, and we'll compare the values and compare it with the IEEE standard 82000. So when I enter, you can see according to our full data, we have passed. We have passed in the sense that when you compare the mesh voltage with the tolerance touch, you realize that the mesh voltage is below the the tolerance touch according to IEEE, and then our grid resistance is less than 0.31. So, and you can also compare the calculated step voltage to be 560.55 volts. When you compare it to with the tolerance step, you realize that it is below the tolerance step. So it means these are field data we have passed, and we can use this our field data to construct or to design our substation grid grounding. Yes, so you can see all the values here. Okay, so you can compare them with the paper or any other values, or you can even use MATLAB or ETAB to confirm which the values or with the authenticated or the durability of the app. You understand? Okay, so you can see. So the report says that since the mesh voltage is below the tolerable touch voltage and the calculated step voltage is below the tolerant step voltage and the grid ground resistance is less than 1 ohms, then the design may be completed or otherwise should be revised. So therefore, if the GPR is below the tolerant touch voltage, then no further analysis is necessary. The design may only need to undergo refinement. Thank you. So this is the report saying that our full data here, we have met the requirement of the IEEE standard 82000. Okay, so let's manipulate the data. Okay, now let's raise the resistivity of the soil and then compare it, and then we'll look at something here. So when I raise the soil resistivity to 100 ohms, now let me enter. Well, that is it is 4. It's error. There's a problem here because when you compare the mesh voltage and the tolerant voltage, no, it's higher than that. Also compare this one with that, is higher than that. So definitely our full data here is wrong. You understand? So that means this our research or this our data depends solely on the what, the resistance of the what, grade grading soil or the resistance of the soil. So he's saying that since the mesh voltage is more than the touch voltage and the calculated voltage is more than the step voltage, then the design is to be revised. So try doing the following. Now, reduce the grade grounding resistance value by increasing the number of rods. Of course, when you do that, we are going to do some changes here. We can also improve the soil resistivity of the grid grounding, as I said earlier. We can also increase the buried length of the grid grounding conductor. We can also connect main grounding to an external grounding grid. Thank you. So you can see, have the report here. You can also view the report also here. You can have the report also here. You can also generate the report in Excel. So when I enter or when I press here or to generate the report in Excel, he's going to the app is going to create a desktop Excel so that we can also use for our report system. So when I enter this one and I minimize that, you can see the 50 kilograms of data. When you enter or when you open it, you are going to see all this our data that we have gotten or we have retrieved from the app. So as you can see, okay. So let me go back to the app. You can also do 3D graphing here to visualize the GPR. So as you can see, this is our GPR. You can compare it, you can also save it and then download it and then use it as your report work. So in this note, I'll end this tutorial here, and then the subsequent video I will try to see if we can do updated version. So your comments is welcome so that we can able to do effective, well grade grounded design. Thank you very much.